everybody, Coach Mark here. Today we're going to talk about the impact of temperature to our golf ball. We live in a climate where we play golf in cold weather as well as in warm weather, and we need to understand how the golf ball reacts in the various temperatures. We'll do a scientific experiments on how we can measure the impact of the weather and the cold on the ball, as well as I think we're going to learn a little bit about the history of the golf ball and understand the materials that are inside the golf ball and come to some conclusions after our experiment and really understand the impact to how we play our game when the weather is cold or warm and how far the ball will travel. So stick around, we're going to have some fun and let's go. Before we get into the experiment, I think it'd be interesting to look at the history of the golf ball, the materials that those golf balls are made of, and explore the modern golf ball and look at what's inside, so when we do our experiment we understand what we are impacting relative to the temperatures of the ball. So let's take a look at the history. The first golf balls from the 14th century were made out of wood, specifically beech, by carpenters using hand tools. They weren't very round, and it's safe to assume that they really were not that great. The 17th century saw an improvement in that wooden ball with the evolvement of the feathery ball. It was basically made from leather that was stuffed with very wet bird feathers, chicken or goose, and they would stuff it very tight, pack it tight, and then sew it shut. And it behaved very differently when wet versus dry, and they were never perfectly round. Plus, because they were so difficult to make, they're very expensive because of the time it took to make the ball. In the mid-1800s, a gentleman named Robert Adams Patterson made the first molded ball. He discovered that the sap from a specific tree native to a country called Malaysia could be heated up and placed into a round mold and then dry hard. They called it the gutta, or sometimes called the gutta percha. These are the first balls with the ability to be made on a large scale, and with the added bonus that they could be reheated and remolded if they're out of round. An additional note that an interesting discovery was made. If you owned one of these gutta balls for a while, it got nicked and banged up from regular use. So as people observed that when you hit a nicked up ball versus a brand new one, the roughed up balls actually had more consistent flight path. So they started purposely nicking these gutta percha balls up to improve the flight path. In 1898, a gentleman named Coburn Haskell invented the rubber ball. The ball featured rubber thread wound around a solid rubber core. There was a popular patterning of the ball that involved mesh, surface, or reverse mesh, and other patterns that would make the ball fly through the air better due to the aerodynamics and the pattern on the ball. This was a major game changer for golf in general, had a major impact on the progression of golf and the progression of the golf ball. In 1932, the modern ball evolved from that rubber ball I just talked about, and this is the ball that we still use today. There's been a lot of technology that's been built into the ball. As you can see on the ball, there's many layers of balls. There's multi-layer, 3-layer, 4-layer, depends on the ball. As you can see, it's got a soft rubber core and a mantle, as well as a pattern of dimples on it to help it fly through the air. And what we'll be studying in this experiment then is what's the impact of the cold on that solid rubber core or the golf ball in general. How does it react when it's cold, and how does it react when it's warm? Okay, let's jump into this experiment and see how the temperature affects the golf ball. So you saw the trials of the experiment, and you saw the results of the data that was collected, and you can see that temperature definitely impacts the performance of the golf ball. So why do balls bounce? Well, there's a couple things involved. One is gravity, and gravity pulls a ball toward the ground. You know, what the ball is bouncing off of affects how high it bounces. This experiment was bounced off of concrete. If we bounce it off of a softer surface, the ball wouldn't have bounced as high. Should have had a similar result between a cold one and a warm one, but they wouldn't have bounced as high. And also the material inside the ball affects how high it bounces. As you saw in our golf ball review, you could see the core of the golf ball has elastic material in it. So that elastic material is affected by the temperature. So the colder temperature has less elasticity in the ball, and you can see that that definitely had an impact on the performance of the ball. Okay, so some closing questions. So as you look at this, what conclusion can you make from the results we saw? We talked a little bit about it a little while ago about the results. So think about that and answer that question in your mind, as well as what's the difference really between the two golf balls? What was the impact of the results? And then the real key one here is, okay, we play in Michigan weather where it's cold and it's warm depending on the time of season. How would you adjust your golf club selection based on the temperature outside? So if you hit a pitching wedge 100 yards and it's 50 degrees out, how would you adjust? Would you go to a 9-iron, something to hit the ball a little farther, because you know that the golf ball, because it's cold, won't travel as far? So this experiment's a very practical experience, and I know personally when I play in cold weather, the golf ball does not go as far, and I adjust my club selection accordingly. So this is something we can apply to the golf course. Okay, thanks for watching. Hopefully you learned something today, and always seek new knowledge.